Hello everyone. In this video, we'll take a look at how to use the Orange data mining application to perform some time series forecasting. We'll use the same data set that we used in the Excel forecasting series so that we can compare our Orange model against the manual models that we built earlier. So let's begin. Hopefully you've already downloaded the Orange data mining software. But if you haven't, you can download it from their website, which is just orangedatamining.com. And once you get to the website, there's lots of resources here to give you some additional information about the software. But on the main page here, just to get access to it, you want to go to the Download Orange button, click on that, and then you'll see it's available for 3 popular platforms: Windows, Mac, and Linux. I'm on a Mac. And you just go to the download and go through the basic install instructions that you would for either of these platforms. If you're on a Windows machine, you get an executable, you download it, walk through the installer. And on Linux, the process is a little more involved, but nothing too crazy. So those are your options for getting access to this particular software. So if you don't have it already, pause the video, take a moment, download it, and get that installed on your machine. I'm going to fire up Orange here. And the software runs, it's pretty basic. It's a kind of a multi-document interface. So you'll have your main interface where we'll do the majority of the work. And then there's a number of additional windows that'll pop up that you can use to change the settings for your widgets and things like that, view results. So we'll see all of that as it relates to the time series forecasting that we're going to do here in just a minute. So I'm going to, from the main pop-up here, just select a new. You'll notice there's a couple of other options here. If you have an existing Orange workflow, you could open that at this time or look at some examples. We'll just go with creating a new document at this time. And then once you've got this opened up, you'll see the interface is pretty straightforward. So the nice thing about Orange is you don't have to have a really deep understanding or knowledge of the mathematics that are involved in everything that we're doing. So kind of unlike what we had seen with the Excel models that we built, here we're not going to be really directly influencing or working with any maths. What this tool does make available to you are a number of widgets that are all grouped over here on the left-hand side. So you've got data, visualization, model, widgets, etc. And the ones that we're going to have to, well, we're going to use a couple of the ones from above, but the one that we really need access to in this case, because we want to do time series forecasting, is the time series set of widgets. And so by default, you won't have these available. You'll have to include them in the software itself. So once you've got Orange up and running, if you go to the options menu at the very top and select add-ons, it's going to do a little retrieval of all the lists, or sorry, the packages that it has available in a list. And then you can see here from the list that I have, there aren't a large number of them, but your mileage may vary. If you've got a lot of available add-ons here, you can just filter them down by typing in time or time series. And that should narrow it down to the Orange 3 time series add-on. Just make sure you check that box and go ahead and install the add-on. It might require a restart of the software, and if that's the case, then that's fine. Let it go through the download and restart, and then once you're finished, you should see over here on the left-hand side that you now have the time series set of widgets available. And so now that you've got the time series widgets available, we can go ahead and build our time series workflow. And so like I mentioned, working with Orange is pretty straightforward. I mean, essentially we just drag and drop widgets from the left out into the workflow space over here on the right and configure them and connect them together to produce some desired result, whatever that happens to be. So for today, we're going to be looking at creating a time series forecast model. But in other cases, you might be looking at performing some predictions based on linear regression models or k-nearest neighbors models or something. So there's lots of other things that we can do. But for today, we're just going to be looking at time series forecasting. And so if you want to get more information about the widgets, you're not going to wreck anything in here, but if you click on and expand the different areas that we have available, you'll see all the different widgets that are included. And if you just mouse over them, you kind of get a title at the bottom area here that gives you a brief explanation of what that particular widget is. If you click on a widget, it'll just add it immediately into the workspace area, which is kind of fine. Or you can click and drag them on. And once you've got a widget here, if you accidentally clicked on something and it added it, you can just click on or select that widget and then hit your backspace or delete key, and that'll get rid of it. Or you can right click and you can choose to remove it as well. So again, don't worry too much about making mistakes. That's probably not going to happen. I think you'll be fine. And if you do want to get more detailed information about these widgets, you can get that again from the Orange website. So if you go to the docs link at the top of the Orange website, that'll bring you to the documentation for Orange. And you're going to want to spend some time over here, getting started. There's a link to a number of YouTube tutorials, loading your data, which we'll take a brief look at in this video as well, and then the actual widget catalog itself. So if you select this option, right, you can see all the different widgets that are available and get a more detailed breakdown of what those widgets are all about. So lots of information on the website. Don't discount that. If you get lost or you just want to know more, then go in and visit that site. Okay, so to get started here, the first thing we need to do is to load our data into the workflow so that we have the data to work with. And so I'm just going to use the same time series forecasting spreadsheet like I mentioned that we'd used before. So I've got that here on my desktop, but wherever you've got that on your machine, just make sure you have access to it. And if we go to the data section of widgets, we'll see there's a number of options that we can use at the very top row for loading data into our workflow. And this is just an Excel file. It's not necessarily a CSV file or explicit data set or a database table. So we can just use the simple file widget to pull that in. And Orange is pretty smart. It's going to recognize it as an Excel workbook, and we could select data from different sheets. So we'll just click and drag that onto the workflow. And once it's here, it's not really doing a whole lot. If you double click a widget, that'll bring up the configuration window for that particular widget. So in this case, I'm going to go and try to find my file. It's on my desktop, and it's my time series forecasting Excel spreadsheet. And once that's loaded, you'll notice here it recognizes it as an Excel spreadsheet, and there's a little drop down beneath it where I can see the different sheets that I have available from that workbook. So there's the original data that we had in the initial sheet, the forecasting models that we built up, and then I had a sheet where we had 2 charts. So, and if you're not sure or don't remember what that looks like, we can go back and revisit the spreadsheet itself. So the first sheet, the Edmonton November 2020 single family, is just two columns, dates, and the single family benchmark, again going back to January of 2005. So that's the sheet that I want. And then if you look below, we'll just reload this. There we go. Sometimes it takes a second. If you don't see in this area here the actual columns that you expect, just do a re-click here on the sheet, and then hopefully that loads it up for you. In some cases, clicking the reload button will get it to do it for you too. But we can see here there are 191 instances. There are 2 features with no missing values. So it gives us some information about the data that we're working with. And we can see below here our 2 features are a date and a single family benchmark column. And there are 191 instances of those particular records in this data set. And then we also see here that type. So it's going to look at that data and try to determine what type of data it is. And so in this case, it's correctly identified that we have a date time format data, and then we also have just numeric data. And beside that, we also have a role column. And the role is important. So the role of the data is to tell Orange how we want to treat this data in our workflow. And so if you click here, you'll get a little pop-up that has a number of different options. Features, targets, meta, and skip. Whether or not you want to include that data at all, you could choose to skip it right here in the file widget. If the information represented by this particular field is just meta information about the data you're working with, you could select that. The target is to say that this is the target variable that we want to predict for in our case. And so for us, what we're trying to make predictions or forecasts for into the future will be the single family benchmark value. So we'll be making sure that this is our target. So, and then features are, again, a means to identify variables that will be included in a model that we use to determine or help make a prediction, for example. So in this case, the date isn't really a feature. You know, it doesn't actually help us predict. It's just there to indicate when the value that we're looking at has been recorded. So we might choose to mark that as a meta. So it's information about the data when it was recorded. So let's update the date to be meta. And we've already got our single family benchmark field identified as a target. So that's super cool. We're good with that. So we can just choose to apply and then close this. And nothing has really happened if you look on the page. But at this point in time, our file's actually been loaded into Orange. And so we've got a number of other widgets that we could use to explore that data, or just to test that we actually have the data that we want. One useful widget here is the data table. And like it says below, this basically allows you to view the data set in what looks like a spreadsheet. So if we drag that onto the workflow space, we can have a look, double click it, and that'll open up the widget so that we can see the contents. And so here we do see our 191 instances. We have a meta attribute, which is our date, and here's the single family benchmark value. So we can actually visualize and see that, yes, this is the data that I want. If there were additional columns in the data set that we wanted to remove, we could verify that we had removed them either through the file widget itself, or I'll close this, or through something like the select columns widget. So I had done some work here on the columns directly in the file widget itself, but there's also a select columns widget that if we were to feed the data into and we open that up, basically allows us to do similar adjustments. So here the window appears a bit different, but we can see our two fields that we have, and they're, again, already identified via our file widget as a target, which is our single family benchmark, and a meta date field. So if we had other columns that were available, they would appear here. We could choose to remove those, or update our target variables, or add meta attributes. So the select columns widget is useful, not in this case because we only have the two, but in future examples, if you, again, are working with data sets that have 15, 20 columns, and you only want to look at 5 or 6 of those, then this select columns widget is useful for paring that down and quickly visualizing where all the columns appear, whether they're features, targets, meta, or they're skipped altogether. So we don't actually have to use that here, so I'm just going to remove that. And now we can just continue to move forward from there. So what we are really interested in, and what we had to do at the beginning, was to enable the time series set of widgets, because that's where we're going to be working. And by default, the data that we've loaded in as just kind of spreadsheet data is not in a format that Orange is going to be able to work with in a time series workflow. So there's a widget here that is called as time series, which kind of does exactly like the name states. It will allow us to take our data and interpret it as a time series object so that we can do this time series forecasts. So we're going to drag that widget into the workflow, and so we can see it here. And I'm going to take my data from the file, and we're just going to connect here, and we're going to click here and connect it to the time series. And the other nice thing about this is you'll see the connectors get labeled, but if you double click on a connector, a little fly up window for that connector will come up with options that are available. So in this case, the only way to connect these to a file and a time series is to take the data output from the file and connect it to the data input of the time series. And so in some cases, you'll see there are different outputs available from widgets, and there are different inputs available on widgets. And you may have to come in here and reconfigure how those connections are working. So for example, here, if I just hover over the as time series widgets, we can see it only takes in a single input and outputs a single output. And so that's fine. If we look at something like the data table, we can see it has a single input, but in this case also supports 2 outputs. So you could have selected data from within the widget itself or just all the data. So be aware that, you know, widgets have varying numbers of inputs and outputs, and you might have to go in and configure them depending on the case that you're dealing with. And so now that we've got this configured as a time series model, the next thing to do is really to say, okay, well, how do we want to treat this data? How do we want to build a model to inspect and make forecasts for the data? And you're going to see here really quickly this is going to come together and is a huge time saver over what we had previously done in Excel. But again, we're kind of insulated from all the underlying mathematics, which is fine in many cases. But if you wanted to know more about what's happening underneath, you'd have to do some investigative research. So there are a couple of models that are available here under time series. There's the ARIMA model. There's also the VAR model. And essentially, I mean, you could compare both of these. But again, I'm oversimplifying for this example. Typically, we would see the vector autoregression model used where we have multivariate time series, or we have, you know, several variables that vary over time that we want to look at. And in our case, we're really only dealing with what we call a univariate data set. So we only have one variable that varies with time. So I mean, you can kind of get that from the pictures here where there's like a single line chart here. There's two. So to just cut back on what we're going to look at here, we're just going to work with the ARIMA model here. And you'll see it's using the ARMA and ARIMA, or the ARIMAX. And that all has to do with just the various components that are used to comprise this overall model. Really quickly, there's really three parts here. There's autoregression, or AR, there's integrated for the I, and then there's moving average for the moving average piece. And those three components are brought together in this model. And again, you don't have to know the underlying maths that go into how this is going to be built, but there are some well-known cases that we'll quickly explore in this example. So I'm just going to drop this model onto the page, into the workflow. And again, if we look at this, we can see, I'll just hover over it, that this takes in a time series and potentially exogenous data. And then it outputs a number of things. We get a time series model. We can get forecast values, fitted values, and residuals if we wanted to look at errors and things like that. But we're not going to deal with most of that. Again, this video is really just to walk through the forecast piece of using Orange and the time series widgets. So we're going to connect our time series to our model. And here, because there are multiple options, it gives us the fly up to say, well, how do you want to connect these two widgets? And I do want the time series data to go in as time series data to the model. So we can click OK. Okay. And so that's fine. And so right now we have our data going in. We have the model set up. It's all it's already configured with a default set of settings. So we could begin to get forecasts out of this model at this time. And so to be able to see those, we can again just bring a data table onto the page. So we'll add that to our workflow. And here it's going to ask us again how we'd like to connect it. So the data table only takes input as data, but we have three different values we could output here. And you could connect all of these up. If you wanted to see the residuals and fitted values, you could do that. But let's just keep it clean. We'll just deal with the forecast data only. And so now when we open this data table, we can see the information that's provided. So in this example, it's set up to provide three forecasts into the future, and we could see those values kind of set up here. Now you might be asking, like, well, where are these values coming from? And they're based on settings that are in the ARIMA model itself. Now, if you've used the software before and made adjustments to the settings in some of these widgets, then your values here might appear a bit different than what you see on my screen right now. And so let's just go back in time here and revisit our model itself. If we double click, we'll see a fly up for the options that are available. And so you can see here, I've already got a couple of updated values here. So number 2 for my differencing degree and number 2 for my moving average order. But in your case, you might have something where they're just all initialized to zeros, which is kind of effectively just like a white noise model. And down below, we can see the number of forecast steps to produce into the future. So let's just reduce that down to 1 so that we're all kind of at a base level so that we can explore this together. And then down below the forecast steps ahead, we also have an option here to update our confidence interval. And what the confidence interval represents is kind of exactly what the name states, and that is how confident can we be that the forecast values that are coming out of this model are, within 95% of what we would expect the mean average. Okay. And so the wider that confidence interval is, the larger it is, right? The more confident we can be that the forecast is something that we would potentially see, let's say, in the real world. If we were to narrow that down, let's say we wanted only a 30% or confidence interval. Now that we've narrowed that right down, the forecast values that are going to come out, it's going to be very difficult to predict, with a confidence interval of 30%, what the value is going to be. So we don't have to mess around with that too much. Typical in these types of experiments is to have a 95% confidence interval. But to say that you can produce a model that has a confidence interval that's very low, like 30, for example, will be very difficult to prove, right? You're only 30% confident that the forecasts are usable, right? Well, if I came to you and said, well, I'm 30%, confident this is the case, you're probably not going to go ahead and make a decision based on the data I'm presenting. Whereas if I come to you and say, I'm 95% confident in that these values are things that we can put our faith in, then you're more likely to go with those values. So again, don't read too much into it, but there are some, studies that look at, how to set confidence intervals and what's accepted. But typically you would see a 95% confidence interval being used. Okay, so now that we've kind of updated this to kind of our base piece, and we'll come back and revisit these values in a moment. We'll just close it out. We'll go back and revisit our data table. And so now you'll see that we have just a single forecast into the future, and we've got this value, which is 354. If we remember looking at the data itself, our final recorded value was 380 and some change. So this is quite far off. And then along with the actual benchmark forecast value, we also get the low end of the 95% confidence interval, and we also get the high end, right? And so you'll see here there's quite a large spread, right? And that's where that high level of confidence comes from. I mean, we're saying the value, we're 95% confident that the value is going to be between 260 and 449,000. Well, yeah, I mean, you choose a wide enough range, the confidence level is going to go up. So reducing that confidence interval would narrow this window, and you can experiment with those values to see what that will do in the model and the data on your own. So I'm just going to close this, and we can go back and revisit the ARIMA model. Or actually, before we do that, let's just give ourselves another way that we can visualize this. And so if we go back to the time series set of widgets, we'll see here that there is a line chart widget, okay? And it allows us to visualize the time series sequence and progression. So let's just drop that onto our workflow. Okay, and then we can connect our model to the line chart. And so that's going to be our forecast value that's coming out of the model. So let's connect our model to the forecast and say okay. And then we want the actual data to be coming from our time series widget. So we can connect that up here. So our time series is going to be giving our time series data, and then our widget is going to be providing our forecast data. I'm a stickler for making these things, look, in my opinion, nice, so I'll be moving those things around a little bit. Okay, so if we go and have a look at this line chart, we can select the single family benchmark value that we have, and we can see exactly what that looks like. So we've got all the data going back to 2005 included in this model, which again, in our Excel build, we didn't do that. We removed a lot of that. We only went back 2 years. So we'll look at how we can adjust that here in a moment. But we can see way at the very end, right, here's our final recorded values, 380,000, and then it drops to our forecast value. So you can see that here. And so looking at the data, you might say maybe that's possible, but I mean, how much faith that we're going to put in that as a forecast, I don't know. So this is now where we're at. We kind of encountered the same place when we were working with the Excel data, is that, I don't know if that's really accurate. Are there things that we can change in the underlying model to maybe get a what we feel is a more accurate or believable or workable forecast value. So let's close this line chart and let's just shore this up a little bit. So let's just look at our data and say, you know, I really don't want all the data going back to 2005, similar to what we did in our Excel build. So let's update this. I'm going to remove this connection between the file and our time series model. And I'm going to go back to the data set of widgets, and I'm going to insert a select rows widget, which will allow us to do exactly what it sounds like. We'll be able to select the rows that we want to include in this data. Okay, so once we've connected these two, we can go into the select rows widget, and we can see here that there are some options. And for me, this is kind of already set up. Again, if you've worked with these widgets before, the settings carry over. But I want to look at the date, and I want to include only rows where the date is greater than, in this case, I've selected 2018 in October. So I want November of 2018 and on. That's what I want to include. And you could add additional conditions or modify these or change them. But those are the rows that I want to include. And you'll see that down here at the bottom, it shows you we have 191 instances coming in. And with this current filter, we're going to spit out 25. So I say, okay, that's fantastic. And now we can wire our select rows into the time series widget. And then that will have an impact on the remainder of the workflow. So now we only have the 25 records going in. If we go and look at our line chart, we can see here now we're going back only to November of 2018, and we get kind of a better picture of what that forecast looks like. So again, so select columns here would allow us to choose which columns we want to include, and then you can use select rows to narrow that down in terms of the number of instances that you want to include as well. All right, so we're kind of in the home stretch here. All that's really left to do is to make adjustments to the model to see if we can't get a better impact on our line chart and our forecasts going into the future. And again, without getting into the deep mathematics of it, we'll have a look at our ARIMA model here. We'll make some adjustments. And again, there are some well-known cases, but you can kind of reason about the adjustments we're going to make based on the 3 different components of this model as well. And so let's just kind of rejig our space here so that we can have a look at a number of these things kind of all at once. I'm going to shrink this up a little bit. And so in addition to the widgets we already have on screen, I'm going to add one final widget. If we go to the time series set of widgets, you'll see there's a model evaluation widget here, which is exactly, again, what it sounds like. It allows us to evaluate our model as we make changes. And so I'm going to drop that onto the workflow also. And I'm going to connect my ARIMA model to, to here. And time series model, that's fine. And then we also, again, here need the actual data so that we can do our evaluations. Right, so at this point, we've kind of got our full workflow set up. For this example, there are no additional widgets that we're going to include. We've got everything that we need to work with making forecasts in Orange. Now it's just a matter of, like I said, tweaking things a little bit to get them to where we might like them. So I'm going to open a number of windows here. So let's get our data table. I'd like to have that available so that we can see what's coming out in terms of our forecasts. I'd also like to see our model evaluation so that we can leave that here like that, so that we can make sense of, let me actually shrink this up a little bit. There we go. Yeah, and we'll come back and look at this model evaluation here in a moment. Don't worry too much about the number of folds or forecast steps at the current time. We'll also get our line chart available, so let's pop that up here. And then we're going to make adjustments now to our ARIMA model. And so having all these other windows open and visible is useful so that, you know, as we make changes here, we can immediately visualize and see what the effects are in these other cases. Taking a moment here to just briefly talk about the model evaluation, you'll notice that here we can see our various accuracy measures. So our RMSE, MAE, and MAPE, which correlate to the same types of accuracy measures that we had created in our Excel spreadsheet. So if we just briefly go back and visit there, in our forecasting models in the spreadsheet, we can see our mean absolute deviation, our mean absolute error, and then our mean sum squares, but we kind of moved that to the RMSE. So here we got a value, and then our MAPE as well. So with these accuracy measures, we can now compare what we're doing in Orange back to what we were doing here in Excel. All right, and we had just basically a rolling or simple moving average, and then we had our exponential smoothing, and then we applied our double exponential smoothing or Holtz method in the final case. So this was kind of like our best result option. And of course, here we could see that we were able to make numerous predictions into the future beyond a single forecast prediction. So now that we've got these accuracy measures set up here, and we've got the same in Orange, we can do some brief comparisons. And right off the hop, with kind of our default ARIMA setup with just zeros here for the AR differencing and the moving average piece, we can see that this model doesn't do very well. So let's just take a moment to briefly talk about what we're looking at here. The number of folds is essentially just to say the number of times that the model is going to train itself on the data. So the higher the number of folds, typically the more confident you can be in how it's performing. And you want to, if you can, use not as many as possible, but a higher value is better than a lower value. And because I've limited the number of instances that we're looking at to 25, we're not going to be able to go with like the default, I think, of like 20 folds. It's going to complain and say, you got too many, it's not applicable, or might give us an option. But if we increase these up, the number of folds, you can sometimes see what effect that's going to have on the data. So I've jumped that up to 15, and you can see that that has affected the RMSE. So it's gone down a little bit, but still not quite as good as what we had seen in our Excel spreadsheets. And then we can also look at the number of forecast steps ahead. If you want, you could try to increase that. But now, as soon as I start messing with these values, you'll see here, like I mentioned, the supply time series is too short to do this. So for one, we're able to go into a higher number of folds. But as soon as we want to look at maybe 3 forecasts in the future, or even 2 in this case, starts to fall apart. So we'll come back and we'll readjust these once we're kind of finished adjusting the numbers here on our forecast steps. And the last thing I want to say here is just regarding this. We have the ARMA in this example and the ARMA 000 in sample, and this is just a comparison between how it's applying the model onto the actual test data. And here it's just on the training sample. So ideally, you want to see the error measures, relatively close between these two. The closer they are, I think, the better you could say the model is working. But really, we're not interested in the in-sample values. We're interested in the test, because this is just based on in-sample training data. This is including a tests partition so that it actually does a comparison. So train the model, and then apply the model onto data to see how well it works. So we're interested in not the in-sample measures. We're interested only in the model itself. So these numbers are the ones that we want to take a look at. And so now that we have this set up, we can come back and revisit the actual settings themselves. The way we have this set up right now is to not say that it's doing very much at all. But if we take these parameters, P, D, and Q, respectively, to attach them to the 3 different components, so our autoregression, integrated, and moving average components of the model, we can update them here. And in this case, we really are just dealing with moving average, so I'm going to stay away from the autoregression piece. We're not going to adjust the order here. But like I mentioned, there are some kind of common use cases. So to just kind of oversimplify, let's start at the bottom and just talk about moving average order. And if we increase that by 1, we can see that that's going to have an impact here. We automatically have the changes applied. So we can see in our data table the new forecast value. So just by changing this one moving average order parameter, we've improved the benchmark forecast, right? The low and the high ends are updated as well. And then we can see here the RMSE is also improved, and we can take a look at the absolute error and the absolute percent error as well. So this is looking much better. And if we want to visualize it, we can come up in here and then just reselect your single family benchmark, and we can see here it's moving a little bit better. So again, a highly oversimplified description of or explanation of what we've done here is basically to say we want to use this model to just apply a simple like a moving average model, which isn't quite the same as a simple moving average. It includes the forecast errors in the model itself, but we can see what effect that has on our forecast. So if we compare this would be, the most relatable comparison would be to our moving average values here. So if we come back in our Excel spreadsheet, we can see our 4-month and 3-month moving averages where we had our benchmark values. So they're fairly close, right? So 376, 377, and 378 for our 3-month. And then if we look at the accuracy measures, right, we can see our RMSE is 3179, and here we have 3085 for our 4-month, but our 3-month was 2621. So our Excel, simple kind of moving average is performing a little bit better than what we've done here. And so again, this is how we can use these accuracy measures to make the comparisons between models. So if we move along here and adjust this one more time so that we have a differencing degree, this is essentially equivalent to like a basic simple exponential smoothing model. So we would expect now to be able to compare this to what we had done in the middle of our modeling. So our exponential smoothing, where we can see the results here. And now we should be able to make a comparison in what we see in our orange model. So once that adjustment's been made, so again, effectively exponential smoothing, we can see here again the RMSE value has been improved. Our benchmark value now is kind of in the same neighborhood. It's marginally positive, which is kind of a good sign looking at what we had done. And if we go back and revisit our chart, we can see here now the visualization of the forecast is in a positive direction. And so again, we can compare that with our values in Excel. So our forecasted value here was 378. And so here we have a 380. So this, I would argue, is actually performing a bit better. We can also compare on our accuracy measures. So RMSE is 2064, and here our RMSE was 2144. So this is performing better now in orange than we had in our spreadsheet, right? Comparable, but better, right? And the mean absolute is marginally higher, but we're getting a root mean square error that is better. So again, when you would use, for example, RMSE or consider it is to say, if you're looking at these two values, larger errors are more highly kind of penalized than lower errors. So the RMSE value can indicate, whether or not, absolute deviation may be one thing, but whether or not there were some kind of outliers in the actual errors themselves. So a lower RMSE would be a better indicator for a model that's performing more to our liking than another model. And so the final update we can make to this model here would be to go to double exponential smoothing, which would be the equivalent of having a differencing order of 2 and a moving average order of 2 here as well. There's also what's called a damped Holtz model, which is where we reduce the differencing degree to 1, but have the moving average order at 2, and we could revisit that as well. But for now, we're just trying to compare, as much as we can to our existing models in Excel using the Orange software. So this final setup here for the ARIMA model, where we have D2 and Q2, is effectively equivalent to our Holtz method or double exponential smoothing. And we had 3 forecasts into the future there. So we'll update our forecasts here to match. And you'll see now you'll get like some strange results in some cases where you get these NAND values. Oops. And yeah, we'll come back and revisit this in a moment. The forecast steps here in the model evaluation, we want to update to 3. And this is, again, where we'll see the supplied time series is too short. So we'll have to reduce the number of folds that we can apply. And it looks like 7 gets us there. But to deal with these NAND values, because the the series is too short, we're not going to be able to get good measurement accuracy measures out of this. So we'll have to just make some adjustments here. We'll drill this down. We'll keep the forecast steps at 1. I think that's fine, and we can increase the number of folds. Yeah, 9, no 8. I think 8. Can we try to get the highest number of folds that we can get applied here. So, all right, so that's good. So we can do our model evaluation based on these settings, even though we're forecasting 3 steps into the future. Again, this just gives us some idea of, like, for that first forecast step, what are we looking at here? And then we can get a rechart for that in our line chart. And so we can see into the future our 3 forecast values. We can also shrink this over here to make it a bit larger. There we go. And so now we can kind of get a better picture of what these forecast values are looking like. And if we go and compare this double exponential smooth model that we built here now in Orange to what we had done previously in Excel, we can get a look at the accuracy measures and the forecast values. And so let's just get it up way over here. There we go. So our forecast values for our exponential smoothing model are here. And if we do the comparison, right, like 381933, 381990, so they're very close. And then 3839, we have a 3839. And then our final one, there's a bit more error discrepancy between the two in our third forecast out. But these two models are performing very, very similarly. So, you know, without going through the work that we had to do to set up this model in Excel, we could get here pretty quickly in Orange by just dragging, dropping these widgets, wiring them up, making a couple of adjustments. And so you can see here how the Orange data mining software would really be able to save you time when it comes to developing these models. The trick here, of course, is we don't have as much influence over the kind of the knobs and levers that we had in Excel, where we could adjust, you know, our beta and alpha parameters, etc. But we still get a pretty good and desirable result at the end of the day. So looking at the accuracy measures again, so we've got an RMSE of 2088, and in this example, just shrink this down a little bit so it's easier to work with. Right, we had an RMSE of 1,838. So again, based on those measurement values, right, we're a bit out here. We may still say, well, this model has got a better RMSE than this one, but we're limited in the number of folds that I can apply. You know, so I might want to do some experimentation here by selecting some additional rows, for example, maybe increasing the number of folds and seeing if I couldn't improve this value a little bit more. And that's all part of the process, right? There's a bit of experimentation that goes on here, and a bit of applicable knowledge as well. So depending on the context, again, we're only looking at the lags here or the previous values in the data set. We're not looking at external environmental factors and other things that we might want to bring to bear on the forecast for these single family home prices. But given what we have, we're trying to compare one model just solely on its own merits against another. These are the measurements that we would typically look at. One thing I haven't really focused on here is R squared, or a coefficient of determination. And that really comes more into play when we're looking at things like, you know, linear regression and multivariate linear regression. But basically the short explanation of this particular measure is to say that it's a value between 0 and 1, and it's essentially a measure of how much variation in the model or in the data that our model accounts for. So the higher this value, the more confident you can be that your model is going to be accurate. And so an R square of 0.8 is really good. It's, you know, it's hard to know like what's good and what's bad. In some cases, you might get an R square of, you know, 0.4 and consider that to be good. So that's something to be explored more when we look at things like not time series forecasting, but classifications and linear regression. Those types of models, R square becomes more meaningful, but it is presented here as a measure as well. But we didn't calculate an R square in our Excel spreadsheet, so that's why I've kind of largely discounted it. But you can read up more about R square as an accuracy measure, and we'll definitely come back and revisit it when we do some classification and predictions in future lessons. So Yeah, that's kind of it for now. I don't want to say too much else about this. I think we've kind of covered the gist of it. All that's kind of left to do at this stage is, if we're happy with our model, we may want to save this so that we could work with it into the future. And so from within Orange, we can choose our file menu option, and you can just choose to save. And it's going to save it as an Orange workflow file. We could call this, I'll call it time series, and put it to my desktop. And so I'm just going to save that. And now on my desktop, you should end up with this OWS file. And once Orange is closed down, if you want to bring this model back up, you just double click it if the Orange software is associated with this file type, or you could from within Orange choose open. So the file open, and then navigate to that file and then kind of reload this workflow. The one note that I would say to be aware of with opening Orange workflows that rely on external data files is make sure that the data file is also available where your Orange workflow file is. So if you try to open this up and the file that you've linked to here is named differently or is stored in a different location, then it's not going to find it and you're not going to be able to inspect your work. So just be aware of that there are kind of two pieces that we need in order to continue working in this Orange workflow, and that is the saved OWS file as well as the Excel file that we are using as an input into the work structure itself. So that's it. I hope you found this educational, and some of you might have, after going through the Orange build here versus what we had done in Excel, find you enjoyed this a lot more. And that's totally fine. I mean, we want to use the tools that enable us to be effective and productive. And so I've shown you, kind of several ways that we can get at effectively the same result. At the end of the day, moving on, you're going to choose the one that feels better for you. So lots of other resources are available online about this. Like I said, the Orange website has a lot of documentation, so you could go and inspect more about the widgets that are available. If you wanted to learn more about the model that we used, there's links out to the Wikipedia page, and there's a pile of resources online for these types of models and machine learning, etc. So don't be shy to go and search and find that information out for yourself. It's all out there. But it's just kind of like an introduction to how to do forecasting for time series in Orange. This is really kind of the gist of it. We covered enough ground here, I think, for you to be effective. So that's going to wrap up the time series lessons that I have for you. So again, I hope you found them enjoyable. And until the next time,